Okay, so the 9A revision questions, page 376, multiple choice questions 8 to 11. So we're given this weight in kilograms, and we want in expanded form or as a basic numeral. So that's 2, 3, 2. We're multiplying by 10 to the power of 4. So that's 2 decimal places over, plus another 2. That's in kilograms. So that was answer C. Question 9, write this in scientific notation, rounded to 3 significant figures. So scientific notation means 1, 2, 3, 4. This will be 3.2761 times 10 to the negative 4. And we need to round to 3 significant figures. That's 1, 2, 3. So I'm rounding here. 3.28 times 10 to the negative 4. So that's E. 36 to the power of a half. Now, in order to show your understanding, rather than just typing that into your calculator, you know that a half is a square root. Square root of 36 is easy, that's 6. So that is B. So this is about saying, look, a fractional index is confusing. A square root is easy in this circumstance. So I'll write it as a square root and get it to 6. Simplify. Might as well rearrange. So it's 2 root 7 plus 4 root 7 minus 3. Remember, we treat this as like terms, so the root 7s are like terms. That's 6 lots of root 7 minus 3. That's C. Short answer questions. So this is about writing things in a way that's easy to evaluate, because we're evaluating these without a calculator. Now, sure, you can grab a calculator in the test, but use that to check your answer. What you're doing is showing how it's easy. So remember, I am a really big fan of always putting what's underneath the root sign in brackets. So that is, you wouldn't need quite all of this working, I'm just making it really clear. 16 to the power of 1/4. That's not very helpful, but you can write 16 as a power. Might as well go 2 to the power 4 to the power 1/4. Now it's a power of a power. We can multiply the powers. 4 times 1/4 is 1. This is 2 to the 1, which is 2. That's actually very easy to evaluate, even though this looks quite scary. Some of them will just be easy. The cube root of 125 is 5. Because 5 times 5 times 5 is 125. 49 to the half. A half means square root. A half as a power is kind of confusing, but the square root of 49 is dead easy. That's 7. So show the working. 81 to the power of 1/4. Now this is this sort of question. Pop the 81 into brackets and rewrite it as a power, because it's a square number. We've got 9 squared to the power of 1/4. Multiply the powers, that's 2 over 4, which is 1/2. That's 9 to the power of 1/2, which is the square root of 9, which is easy, that's 3. So it's a case of shifting between fractional indices and surds, depending on which one's easy. If we've got a nasty surd, if we switch to indices, we can get to a nice surd. 27 to the negative root 3. Remember the rule, a to the power of negative n is 1 over a to the n. So the first thing you do is get rid of your negative index. This is 1 over 27 to the 1/3. Now, the power of a third means the cube root. Cube root of 27 is one of those ones you should know. 1 over the cube root of 27 is 1 over 3. Ran out of space, we'll move over here. A similar one. 1 over 121 to the power of a half. Power of a half means the square root. 1 over the square root of 121. That's nice and easy. It's 1 over 11. So you see we're switching into surd form when it's a nice easy square root or cube root. We're switching out of surd form when it's not something nice and easy and we'd rather simplify it down. Question 13, simplify expressing all answers in positive index form. That's saying you want to get out of surd form into positive index form. So here it was just evaluate however is useful. Here, definitely get into index form. Remember that things under the root go in brackets. So this will be s to the power of 6 to the power of 1/3. Multiply out your powers. I've got 6 over 2, which is, did I do that right? Oh, sorry, that's a 3. Cube root. 6 over 3, I've got s squared. Nice and easy, positive index form. When you've got a product underneath your surd, remember, you can separate that out. That is the square root of 81 times the square root of t cubed. 81, I'm sorry. Square root of 81 is 9. If you've got something under the brackets, so under the root sign, pop it in brackets, because this is t to the power of 3 to the power of a half. So I've got 9 to the power of t on 3 over 2. Positive index form. Yep, good. All right, so this one. We are multiplying the coefficients and then we're multiplying the x's. 15, 3 times 5, and I've got x to the power of 2 plus a half. Now do not write 2 1/2 up here. You will have to write it as an improper fraction, not a mixed number. You're never going to put a mixed fraction into here. So that is, of course, 5 over 2. Power of a product, remember that each of these gets squared. So that's 3 squared. M to the half squared means half times 2, which is 1. N squared squared is n to the 4. M to the negative quarter, we might as well take that down here and make it m to the 1/4. So that's our first stage of rearranging. We still have to simplify. 3 squared is 9. When I say positive index form, numbers stay as, pronumerals stay as indices, but evaluate any powers of numbers. Now, I've got m to the 1 up here and m to the quarter down here. That's a division, so I subtract. 1 minus a quarter is 3/4, which will be remaining up here. M to the 3/4 and n to the 4 stays up here as well. Positive index form says I'm going to have to change this root t to a fractional index. And it's really going to help because we'll be able to use the index laws to simplify. So often, surd form is scary, index laws let us do stuff. This is t to the 1 over 2 times t to the half. Now it's index law 2, dividing, which means I'm subtracting. So I'm left with t to the half on 2. It tells me to leave it in positive index form, so I don't change that back to the square root of t. I leave it like that. And this one, we'll be expanding out any brackets to start with. Remember, if it's just 2 fractions multiplied together, you can join it into one fraction if you want. So I've got 4, a to the half times 4 means half times 4, which is 2, a squared. And I've got a to the 1/3 times a to the 1, which is going to be a to the 1 plus a third is 4/3. I could have done that differently, it might have been easier to cancel. Then we're going to have to subtract the powers because we're dividing. Here's where it could have been a little bit easier, just to get rid of this a to the 1 and make this a to the 1 minus 1/3. But, you know, whatever, we've done it now. So cancelling out one of the a's, leaving me with 1/3 and 1, says I've got 4a to the power of 2/3. So index laws are usually warmer and fuzzier for the fractional indices than dealing with the surds. But we often want to come back to the surds when it's something nice and easy, like the square root of 49.